This module introduces you to the main types of coatings application, including brush, mitt and roller application, as well as the types of spray painting. Coating application is one of the important factors that control the successful performance of any coating system. The quality and physical properties of a coating material are determined by the manufacturer, but the potential performance can only be reached if the coating is properly applied. Other factors such as surface preparation and the choice of coating for a specific service environment are also important. To become a successful protective coating, the material must be transferred from its primary container to the surface that is to be protected and must then form a cohesive film with desired properties. The film must be dense, resistant to the passage of moisture and other potentially damaging or corrosive materials, and must dry or cure to its solid state. The application process plays a significant role in the film formation process. There are many methods used to apply protective coatings for industrial use, including brush, mitt, roller, hand or power, spray, including conventional air spray, airless spray, or some modification of these. Of these, spray application is probably the most widely used for industrial protective coatings. One or more of the following may influence the choice of the method used. Size and type of job. Bigger jobs are more likely to use more equipment and more sophisticated equipment. The type of job, defined by the specification, will determine what application method is required or most suitable. Accessibility of areas to be coated. Some projects, for example elevated water tanks, radio and TV masts, will place restrictions on the type of application equipment used for practical reasons. Configuration of areas to be coated. More complex areas may be difficult to adequately coat with spray equipment. Large flat areas, for example ships, tanks, etc., are mostly suited for spray application. Presence of critical areas or surrounding environment that could be damaged by overspray from spray application. Increasingly, there is public resistance to debris such as overspray drifting off the job site. Full containment of the work area may be possible, but the use of brushes and rollers rather than spray equipment may be a more economical solution to the problem. Type of coating. Many modern coatings, particularly high solids, high build coatings, are designed for application by spray techniques. Brush or roller application is not recommended and should only be used when spray application is not possible or for small areas, such as repair areas. Availability of skilled workmen. More sophisticated coatings and equipment require significant expertise by the individual applicators. In many geographical areas, the level of skill is simply not available to allow specification or use of such materials. budget constraints. If money is not available to pay for the more expensive coatings or application equipment, choice may be limited to simple materials and simple application techniques. Application method depends very much on the type of coating that is being used. Some specialized coatings in particular may be restricted to a specific application method. Some coatings, which are 100% solids, for example, can only be applied using special equipment such as heated, pleural component airless spray pump or by hand. Conventional liquid coatings, applied by brush, roller or spray, should generally be applied in multiple passes, thin enough to allow proper evaporation of the solvents as the coating dries and cures. Some high-build coatings, particularly those with thixotropic qualities, dry too fast to allow reworking that would occur with brush application and must be sprayed. Other high-build coatings cannot tolerate the thinning that would be necessary to make them pass through conventional spray equipment, and airless spray equipment must be used. Coatings used on porous surfaces should be able to penetrate and fill the surface voids in the substrate, and should be thinned if necessary to ensure penetration. The choice of coating method may depend on the available skill of the workers and the equipment that is available. Application of paint by brush is the traditional method, although in industrial terms it's been largely superseded by spray application techniques. Brush application of coatings is slower than other methods and generally is used for smaller jobs, new construction and maintenance, where application by roller or spray may not be feasible, and for repair or touch-up of damaged areas. For cutting in corners or edges, to achieve good penetration into crevices or pits. In critical areas where spray application, if used, may cause damage because of overspray on surrounding surfaces, such as around sensitive machinery, motors, instruments and gauge glass faces. For stripe coating of welds, rivets, bolts, nuts, edges, flanges, corners, etc. However, there is no doubt that the rubbing action of a brush can be an additional aid to good adhesion. For this reason, brushing is often preferred for application of primers and is also recommended for the general application of underwater compositions. Brush application can be advantageous for application of coatings on surfaces that cannot be fully and properly cleaned. The superior wetting action achieves better contact between the coating and the surface. This is especially useful on rusted steel, where spray application may leave the coating sitting on top of the corrosion layer with little or no penetration, and therefore little or no adhesion. Even when repainting old paintwork for maintenance, it may be helpful to brush apply the first coat. A brush of suitable size for the work in hand should always be selected. Using a small brush on a large area makes it difficult to apply an even coating and slows down the rate of working, whilst using a large brush on a narrow area makes accurate working impossible. In practice, the brush is dipped into the coating and the excess material removed by wiping or tapping the brush on the edge of the container as it's withdrawn. The brush is used to flow the coating on the surface in smooth, even strokes, without undue pressure that could leave streaks or valleys in the coating on the surface. Subsequent application should be made at right angles to the previous coat in a cross-hatch style. This procedure helps ensure complete, even coverage and helps seal any pinholes from the previous coat. The applicator should maintain a wet edge and brush the coating out from a newly coated area towards the previous wet edge. This practice minimizes the visual appearance of brush marks and overlapped work areas. For application of industrial protective coatings, there are three major points to be considered. These are: brush painting is said to achieve superior wetting, brush marks, that is, peaks and troughs, lead to areas of low film build. Consistently high film build is difficult to achieve, and lower film build should be specified. Application using a brush is slow. This can be both positive and negative. Positive slows operator down, makes him look carefully at what he's doing. Negative slows operator down and therefore is more time-consuming, less economical. Mitts are generally made of lambskin and are lined with solvent-resistant material. They have limited use in the application of coatings for industrial use. Generally, they are used on small projects, such as for coating handrails, small diameter piping in racks, etc., where roller or spray application are not feasible. In practice, the mitt is dipped into the coating and is used to wipe the coating onto the surface. The coating film achieved is not of reliable quality, so the use of this type of equipment should be restricted to areas where appearance is more important than long-term protection. Roller application is of particular value on broad, flat areas. Although not so quick as spraying, it is usually quicker than brush application. Another advantage is that it enables the semi-skilled painter to obtain a reasonable and consistent standard of finish. There are no particular difficulties in roller application, and the technique is soon acquired. For large jobs, it is more convenient to work from a bucket than a tray. A perforated grid is placed inside the bucket. The roller being dipped into the paint and then rolled over the grid to remove surplus material and distribute it evenly. With the tray, a reservoir at one end holds the paint. After charging the roller, it is rolled out on the platform of the tray. The covering material for the rollers may be short-haired carpet pile fabric, long-haired lamb's wool or sponge plastic. Selection of the correct length of roller pile for the particular coating is critical to successful application. If necessary, the advice of the coating manufacturer should be taken to determine the best type of roller material. In use, the roller is rolled over the surface in criss-cross strokes, working the material out evenly. Often, material is applied in this way and left, but if necessary, it may be laid off by passing the roller vertically or horizontally over the surface. As with brush application, many modern, high-build coatings are not suited to this method of application, and the application of a consistent coating film is not easily achieved. However, with specialized, high-build coatings, this is possible. Rollers must always be cleaned immediately after use. Problems with the use of rollers generally arise from carelessness with handling technique and maintenance of equipment. Rollers are not effective in forcing paint into pitted areas or displacing residual traces of loose dust and dirt from the surface. There is also a tendency for operators to apply a heavy coat at the beginning of a patch, thinning out to an inadequate thickness before a roller is recharged with paint. The application of thick, high-build coatings is difficult with rollers on all surfaces except the floor, because it is more difficult for the operator to apply consistent pressure to walls and roofs. Pressure feed rollers allow for application of a continuous coating film by supplying materials from a pressurized tank directly into the roller. The roller core is made with a perforated metal case that allows the coating to flow from inside the roller to the outer surface of the roller, where it is readily available for application. A valve on the handle or the tank controls the fluid pressure and moderates the flow of coating to the roller surface. Pressure feed rollers are generally used on projects where large flat surfaces can be coated at the same time. Operator efficiency can be increased significantly with such automated equipment. It should be noted that there may be a significant difference in appearance of coatings, which depends on the application method. Brush, roller or spray application techniques all bring their own characteristic appearance to the finished coating film. Special paint rollers are often used to achieve specific finish appearance. Some coating types, including those pigmented with flake materials, for example aluminium flake, MIO, may be specially sensitive to appearance change, which reflects the application method and technique. For best results and most even appearance, the applicator should use consistent strokes of the spray gun, roller or brush, and should apply the finish coat with strokes in the same direction wherever possible. This aspect is most likely to be significant on highly visible structures such as elevated water tanks and public buildings.